This lesson is on inequalities and their graphs. So we're going to talk about what inequalities mean and how to graph them. So I'm guessing you've probably seen inequalities before, but if not, these are the symbols that represent inequalities. So this lesson is really based off you already knowing what these symbols mean and and working with them. Although I guess if you haven't seen these, hopefully this will introduce you to them. So this first symbol, the easiest way to remember what this symbol means is if you take your left hand and make an L with your left hand, like loser, like that kind of L, and then pinch your fingers together, it makes this symbol. So if you remember the L, then hopefully you can remember less than. So that symbol, let me find it here, not that one. This symbol means less than. Again, make an L for less, and that symbol's less than. If you can remember that symbol, then you know the other symbol means greater than. So this means less than, this means greater than. If it has the line underneath it, then we just add the words or equal to. So this is the less than symbol with a line underneath it, and so that means less than or equal to. And this one means greater than or equal to. All right, so let's move along. So this says write an inequality that represents the verbal expression and graph it on a number line. All real numbers x less than or equal to -7. So we just want to write this as an inequality. So we say x less than or equal to is this symbol, and then -7. So x is less than or equal to -7. Now we're graphing inequalities. We're either going to graph it with what we call a solid circle or an open circle. If the symbol does not have the line underneath it, meaning or equal to, then we use the open circle. If the symbol has the line underneath it, less than or equal to, greater than or equal to, then, excuse me, I'm sorry, I'm trying to get over this cough. So if it has a line underneath it, then we use a closed circle. So on this number line, instead of putting all the numbers on the number line, I'm just going to put 0 in the middle. I'm going to put 7 over here and -7 here. And then since this has a line underneath it, I'm going to put a closed circle at -7. And then this says x is less than or equal to -7. And what we're doing on the number line is we're graphing all the values that x could be. So we're showing you what values can x be. The solid circle tells us that x could be -7 because this said x is less than or it's equal to -7. So the solid circle says, okay, x could be -7 or it could be anything less than -7. So what we want to do is shade where the values that less than -7 are. And so the values less than -7 are to the left. On a number line, as you move to the left, the values become less. And as you move to the right, the values become greater. So a value to the right is always greater than a value to the left. So this picture shows that x could be -7 or anything to the left of -7. All right, so let's look at another one here. 6 is less than, 6 less than a number k is greater than 13. 6 less than a number k is greater than 13. So 6 less than a number k, so that means k minus 6 is greater than 13. So that would be the inequality that we. So in order to graph this, let's go ahead and solve this for k. So let's get the k by itself. So hopefully you've done solving one-step equations before. If not, you'd probably want to go reference that. So to solve this, we do +6 on both sides. And so we get k is greater than 19. All right, so now let's go ahead and graph that. So it doesn't have a line underneath it. It's going to be an open circle. Let me number this. So this will be, I'll put 0, positive 19 to the right, and negative 19 to the left. I'm not, just to save time, I'm not putting the numbers in between here, 1, 2, 3, 4, 5, and so on. I'm just putting the numbers that we're concerned with, 19, and then I'll go ahead and throw in negative 19 over here. So I have an open circle at negative 19. This says k is greater than the values, than the value 19. So that's why this is an open circle, because k cannot be 19. K can just be anything that's greater than 19. So the values that are greater than 19 are to the right of 19. And so that's what your graph would look like. All right, let's look at some other examples here. So is the number that's given a solution of this inequality? So the inequality is 2x plus 1 is greater than negative 3. So to see if negative 3 is a solution to that, we're going to plug in negative 3. So what we're going to do is take this value and we're going to plug in for x. So that's going to give us 2 times negative 3 plus 1 is greater than negative 3. And we're just going to use PEMDAS and simplify this and see if we end up with a true statement. If we end up with a true statement, then negative 3 is a solution. So PEMDAS says multiply first. So that gives us negative 6 plus 1 is greater than negative 3. Negative 6 plus 1 is negative 5. So is negative 5 greater than negative 3? And the answer is no. Remember, negative numbers are backwards from positive numbers. So if you think about a number line, if you had negative 3 on the number line, negative 5 would be over here. It would be to the left. And remember, values to the left are less in value. So as you move to the left on a number line, things become less in value. So negative 5 is actually less than negative 3. So the answer is no, negative 3 is not a solution of this. So now we'll plug in negative 1 for x. So plug in for x. So this is like two separate problems. So the first one said, okay, is negative 3 a solution? No. All right, well, let's check negative 1. So we have 2 times negative 1 plus 1 is greater than negative 3. Multiply first, so negative 2 plus 1 is greater than negative 3. Negative 2 plus 1 is negative 1. And negative 1 is greater than 3. That is true. So the answer to this one is yes. So this was no. This is yes. And again, on a number line, let's put 0, negative 1, negative 2, negative 3. I'm running out of space here. Negative 1 is to the right of negative 3. Negative 1 is greater in value than negative 3. All right, let's look at the last example I have for you here. And so this is, if you're given a graph, write the inequality. Okay, so there's two things you have to figure out here. So let me skip this. So I'm going to put my x, and then we got to figure out what the inequality symbol is. We know the negative 1 goes over here, right? That's where our circle is. And now we got to figure out the inequality symbol that goes here. Now, first off, this is a closed circle, so I know it's going to have a line underneath it, meaning or equal to. So the numbers to the right of negative 1 are the ones that are shaded. So that means that x is negative 1 or any value greater than negative 1. And so it would be greater than or equal to negative 1. There's also a little trick I didn't tell you on the last slide. And this trick only works if your variable is on the left over here. So if my variable was over here, this trick doesn't work. And the trick is the inequality symbol is like an arrow, and it points in the direction that you shade. So see the arrow is pointing to the right, so shade to the right. If your variable is on the opposite side over here, then it's pointing in the opposite direction. All right, so a little trick, just be careful with that. Better that you understand what symbol to use and why instead of just using that trick. All right, so let's look at this one. So we have X, we have 4 because that's where our circle is. It's an open circle, so there's no line under it. So this is saying X is any value to the left of 4. Well, the values to the left of 4 are less than 4. And again, there's not a line under it because it's an open circle. So those would be your solutions to that. All right, so hopefully that was helpful to you. If so, give it a like and a subscribe, and feel free to leave me any comments. Until next time.